Today, on how it's made. Top and bowler hats. Solar water heaters. Sticky buns. And electrostatic speakers. Top hats and bowler hats both originated in England. The top hat emerged in the late 1700s as a daring new style, radically higher than the flat three-cornered hat men wore at the time. Then the bowler was invented around 1850 as a lower alternative to the top hat. Today, even women wear bowlers. Top hats remain by and large a masculine fashion statement, reserved for formal occasions, although magicians are still known to use them to produce rabbits. At the hat factory, workers spray a fine mist of water on hoods, pre-cut hat forms made of 100% wool felt. After the moisture penetrates overnight, they steam them for about 2 minutes. The moisture and heat deactivate a chemical stiffener in the felt, making the material malleable. Then they place the hood in an aluminum top hat mold, which applies heat and pressure simultaneously. They place a string in a groove along the perimeter and pull. This rolls back the edge of the felt to form a rim. Then they trim off the excess felt. After about 90 seconds of molding at approximately 110 degrees Celsius, they remove the string and open her up. The top hat is now dry and fully shaped. However, the felt is still malleable, so to reactivate the stiffener and lock in the shape, they set the hat aside for about 30 seconds to cool. To make a bowler hat, the process up to that point is identical, but with the bowler-shaped mold. For both hat styles, it takes 2 sets of hands to pull the hood taut over the bottom part of the mold to avoid creating pleats or creases. There's a separate mold not for just each hat style, but for each size of each style. After the bowler comes off the mold and cools, they give it a second, more precise trimming. Both styles are finished the same way. First, a seamstress takes a wide ribbon, folds it over the edge of the hat, and sews it down on both sides, encasing the edge. Another seamstress uses a gold leaf stamping machine to apply the traditional British milliner's crest and Made in England to the hat's lining. The lining fabric is a silk satin blend. She sews the stamped top piece to the side piece. The machine automatically pleats at regular intervals, so the lining will lie flat against the hat's crown. Bowler hats are more rigid than top hats, so they require an extra application of stiffener inside the crown. Once the stiffener dries thoroughly, which takes the better part of a day, the hat is ready to receive its elegant lining. They attach it with hot glue, which dries almost instantly. Next, they cut a strip of leather to the hat size and sew the ends together with a decorative zigzag stitch. The leather has been specially treated to prevent mildew buildup resulting from perspiration. They sew this leather band to the inside of the hat at the base of the crown, covering the edge of the lining. Not only does this produce a neat and classy finish, the leather band also makes the hat more comfortable to wear by cushioning the forehead. Now it's time to finish the outside of the hat. First, they hot glue a cotton ribbon around the base of the crown. Next, they glue on a matching bow. The grand finale is a small silk satin bow on the interior leather band. Then below that, the manufacturer's label. A few taps with the sticky side of adhesive tape easily remove lint, dust, and wayward strands of hot glue. These elegant toppers and bowlers are the product of several experienced, skilled craftspeople. Hats off to them. Domestic water heaters traditionally run on electricity, natural gas, or oil, for which you have to pay and which have an environmental impact. A newer alternative is a solar energy system. It warms water with the heat of the sun, a resource that's not only renewable, but free of charge. Solar panels absorb the sun's energy, heating water which a pump circulates in a closed loop to a heat exchanger. The exchanger then transfers the incoming heat to the potable water in the household tank. Inside the solar panels are copper strips, electroplated with tin, which absorb the sun's heat. The copper surface must be pristine for the plating to adhere. Therefore, the first operation is a 3-stage cleaning process. Tin doesn't adhere directly to copper, so they first electroplate with nickel, then plate the nickel with tin. The plating is brittle, so to protect it, the next station sprays on a thin coat of liquid glass. The strip then passes through an infrared oven, which hardens the glass into a durable protective shield. As the strip exits the oven, a fiber optic instrument measures reflectivity. The less reflective the surface, the better it absorbs heat. From there, the strip enters a welding machine, which fuses it to copper tubing entering from another feeder. A nozzle sprays cold water onto the mated components, still hot from the welding process. They're wound onto a giant reel. The reel feeds a forming machine, which uses heavy steel rollers to press ridges into the strip. This increases the surface area, meaning it compacts more heat-absorbing metal into a given length of strip. Next, the machine cuts this continuous fin tube, as it's now called, into the standard length pieces required to construct the solar panel's internal piping. Then, a piece at a time, it slices 19 millimeters off each end, so the tubing protrudes. Each solar panel contains 10 fin tubes, which connect on either side to a header. To make each header, workers slide a 2.5 centimeter wide copper tube onto a mandrel. Then they punch 10 holes in the tube, one for each fin tube. They fit the protruding ends of the fin tubes into these holes and weld the connections. The finished assembly is called an absorber plate. It's the key component of the solar panel. The fins absorb the sun's heat and warm the water circulating through the tubes down to the heat exchanger. They pressure test the absorber by submerging it in water and injecting air through the tubes. Any bubbles in the water would indicate a leak to be repaired. Now they cover the headers with a decorative trim and lay the manifold into the solar panel's insulated aluminum housing. The front is a sheet of tempered glass, which allows sunlight to reach the fins inside. After putting caps on the headers to protect them during transport, they apply the manufacturer's label. The solar panel is finished. Now for the other end of the system, the heat exchanger. Its tank is made of welded stainless steel. It has connections for the heat exchanger pipes running to and from the water heater, as well as for the pipes running the circulating water to and from the solar panels. Workers install the heat exchanger unit in the tank, then test it for leaks by filling the tank with water, injecting air through the pipes, and looking for bubbles. If the unit passes the leak test, they drain the water, close the top of the tank, and center it in an ABS plastic jacket. Then they inject expanding foam insulation into the void between the tank and jacket. How does it all work? The potable cold water in the home's water heater circulates through the loop inside the exchanger. It absorbs the heat brought in from the solar panels via a completely separate set of pipes. The potable hot water then exits the exchanger and returns to the water tank. Eat one of these and you'll be sure to find yourself in a sticky situation. But no worries, it's all ooey gooey fun. A sticky bun is all about messy eating. Consuming one is a lip-smacking, finger-licking experience. No utensils required. Sticky buns are sometimes called Schnecken due to their German origins. Schnecken is the German word for snails, which the cinnamon swirl on top resembles. They start with all-purpose flour. Then blend in a premix of sugar, salt, and baking powder. Cream cheese and butter come next. These fats are just the right consistency for an automated dough hook to efficiently work them into the dry ingredients. An employee then pours milk into the blender. It binds the ingredients, turning the mix into biscuit dough. The dough needs to stay cool for food safety reasons, so they monitor the temperature. The next worker loads the dough into an extruder, which squeezes it into a wide, flat strip called the dough band. The dough band rides a conveyor that slopes down to a narrow channel. As it enters, the dough folds over from the sides, creating 2 layers. A roller squeezes the layers thinner. A device called the fanner now zigzags back and forth to layer the dough ribbon style. The layers pile up 6 deep, and because they were originally 2 layers, there are now 12 in total. Metal rollers press the pack down and thin it substantially, until it's about 4.5 millimeters thick. Next up is the sticky bun filling called cinnamon schmear. It starts with blocks of butter and lots of ground cinnamon. They add brown sugar instead of white. It has an intense molasses flavor, and it's stickier than white sugar. Canola oil loosens and homogenizes the ingredients, transforming the mix into the sugary cinnamon paste known as the schmear. This cinnamon schmear is the consistency of cake frosting, so it can be easily pumped over to the dough. A series of nozzles deposit dollops of the cinnamon schmear onto the sticky bun dough. The dough travels under a long blade that spreads the cinnamon schmear evenly. A device called a plow then lifts the outside edges and folds them over. Rollers press down the curled edges to tighten them. Each tightly curled edge will now become the center of a sticky bun roll. Angled rollers called roll winders pick up the curled edges of the dough and fold it into 2 parallel cinnamon rolls. A guillotine blade slices the parallel rolls into buns, creating sets of 2. Meanwhile, the sweet and sticky topping is bubbling away in a big kettle. It's made of honey, brown sugar, and butter. This topping actually goes on the bottom of the baking tray. They pump it into the container and then toss in pecans to give it some crunch. Putting the topping on the bottom of the baking tray means, of course, that these sticky buns are to be baked upside down once purchased by the consumer. It's a strategic baking technique. Cooked upside down, the sticky topping will saturate the buns for added moisture. And by not exposing the topping to direct heat, it won't burn as it caramelizes into a sugary glaze. The sticky buns now head into a tunnel chilled by liquid nitrogen for a very fast freeze. After about 4 minutes, the buns emerge frozen solid with the freshness locked in. The sticky buns then ride another conveyor to the wrapping station. Here, machinery quickly heat seals plastic film around each box of buns. After which, it's into an oven to heat shrink the plastic. It all happens in seconds, giving the frozen buns no time to thaw. It has taken hours of prep work at the factory, but these frozen sticky buns are ready for baking. All the cook has to do is to pop the tray in the oven, and the buns will be ready in 20 minutes. No need to get your hands sticky by making them from scratch. Electrostatic speakers added a whole new vibe to the home music scene. Unlike traditional box speakers, electrostatic speakers are usually tall and skinny, and instead of using an electromagnet to produce sound, they rely on conductive layers of plastic and metal. Electrostatic speakers generate rich audio in the high and mid-frequency range, but they lack the thumping bass needed for full sound reproduction. To compensate, most are now equipped with a woofer. To make the woofer, a computer-driven router cuts out cabinetry parts from veneered MDF. The router carves long grooves. They'll be used to fold it into the woofer box. It also cuts out holes for speaker cone and hardware. A worker glues and drills screws into the bottom of the cabinetry for installing the speaker feet. He trims the excess from the edges of the cabinetry panel. He beads high-strength glue along the joints and folds the grooved panel to create the cabinet box. The glue is stronger than screws and acts as a kind of cement to hold the cabinet together. He sands the wood veneer at the joints for a seamless look. And now it's into the spray booth for the finishing touch, a dark, glossy varnish that accentuates the wood grain. Once the paint dries, a technician pads the inside with a poly-cotton baffle to reduce resonance. He then installs the crossover unit. It splits the audio signal to send low notes to the woofer and the rest to the electrostatic panel. Next up is the power supply and step-up transformer for boosting the amplifier signal. He attaches the assembly to the interior wall of the woofer. He now wires the speaker cone to the crossover unit. He inserts the cone in the slot machined for it, and it's a perfect fit. He boosts the bass with a built-in amplifier. He wires it to the crossover and pops it into the back of the woofer box. This woofer is now ready to be paired up with its electrostatic mate. They make the electrostatic speaker from 2 perforated metal panels. A technician applies a charge to them to check for thin spots. Next, she bends each one to a 30-degree curve. This will allow sound to be more widely dispersed in a room. She presses heavy-duty double-sided tape onto the edges and applies rigid plastic strips called spars crosswise. They stiffen the panels to withstand electrostatic forces. She now unfurls thin but super tough plastic and stretches it to a precise tension. This plastic is the speaker diaphragm. It's been impregnated with a conductive coating to respond to an electrical charge. She positions one of the perforated panels under the diaphragm, and with the backing of the adhesive tape removed, she jacks up the table to press the panel to the plastic. She attaches wiring that will deliver the charge to the diaphragm and make it vibrate. She applies more double-sided tape to the other side of the diaphragm and peels off the backing. Workers position the second speaker panel on the diaphragm and align its fine mesh with that of the panel below. They place the speaker sandwich in a metal capsule to vacuum press it together. Then they frame the speaker with an aluminum border and add a strut to the middle for reinforcement. It's now time for the electrostatic speaker to be joined to the woofer. The tall, slim electrostatic speaker will deliver the high and mid frequencies. The short, boxy woofer will thump out the bass. Then it's into the test booth to confirm that the speaker has the correct range. The technician runs an audio tone sweep and checks for any dropouts in the frequency. Using a special tool, he verifies that the sound waves of the speaker set are in sync, a process called phasing. He then places the speaker in a padded room to test a full range of tones. A computer analyzes the tones. Once it passes all the tests, this electrostatic speaker links up with the rest of the sound system. It's now ready for its audience.